All right, today let us look at something interesting. I don't know how many of you guys remember from grade school how to do arithmetic series. Probably you guys remember it as a formula that was taught to you, and most of you probably don't remember the formula anymore. So this is a problem that I commonly see with mathematical teaching, where people are taught formulas, but they're not really taught where they came from, what happened, how they came about, and what's the use. And so kind of just is there, and then we kind of forget about it. So let us begin, and what we will do is we will look at something here. So let's start. So let's say that we want to calculate the sum 1 plus 2 plus 3 plus 4. Okay, so can you guys add these? Sure. 3, 6, 10, right? 10. Now if I said add up all the numbers from 1 to 100, how might you do that? So you'll say 1 plus 2 plus 3 plus 4 all the way up to plus 100. So an easy way you can think of doing this would be for a minute to ignore the 100 and add up everything up to 99 and then add the 100. So let's put in a 99 here. Let's do this. Let's go plus 99 plus 100. So 99 plus 1 is 100. 98 plus 2 is 100. 97 plus 3 is 100. Right? So if you work this out all the way to the middle, 49 plus 50 plus 51, the 49 and the 51 will be 100. So, isn't that interesting? So now, how many numbers are there from 1 to 49? 49 numbers. So you have 49 100s, so that's 4900. And then you have this 50, and then you have this 100. So add another 150. So the total is 5,050, right? So the numbers from 1 to 100 add up to 5,050. The numbers from 1 to 99 add up to 4,950, right? Not including that last 100. So the trick here is you have to remember that you have to add this 50 on after taking the numbers from 1 to 49, which will add up to 100 with the numbers from 51 through 99. All right, so now that we have this trick, so let's continue exploring adding these numbers. Now let's say I wanted to add numbers from 1 to 77. So how might I do that? So this is where I want to now start thinking about coming up with a more general way of adding numbers from 1 to any number. So here's another idea. Let's say I want to add up the numbers 1 through 4, right? Let's go back to our first example. Let's say I'm going to represent them with dots. So I'm going to say 1 dot, 2 dots, 3 dots, 4 dots. Just arrange them like this. Okay, so now here we have how many dots? 1 dot plus 2 plus 3 plus 4. So we have 10 dots. All right, so why is 10 dots? So how can I use this geometrical triangle here, 1, 2, 3, 4, to figure out that there are 10 dots here? So let's say that I was to double this triangle up. So let's take a different color here. So let's say that I'm going to invert and double. So there are 4 dots here. So I'll go 1, 2, 3, 4. And then I'll have 3, and then 2, and then 1 more dot. So you see, now you know that the number of dots in this here is going to be 4 times 5, which is 20. Okay? And so this original, these red dots are basically half of these dots, right? Because I doubled it by basically taking this triangle and inverting it and adding it on top. So 20 over 2, so originally I have 10 red dots. And so geometrically you can see that adding numbers 1, 2, 3, 4 gives me 10. And I can also figure that out by basically creating this kind of a geometrical structure. And I can extend this structure, right? So I can basically, if I had, let's say, instead of adding up to 4, I wanted to add the numbers up to 5. So again, I can do this. 1, sorry, 1, 2, 3, 4, 5, right? So now I have up to 5, and then I can take the inverted triangle. So add 1, 2, 3, 4, and 5. And now I have 5 by 6, which is, if you multiply this is 30 dots, you divide by 2, so that's 15. So basically we're talking about 15 is the sum of 1 to 5. All right, so now let's note something more. We can do this same trick. So what is 6? 6 is basically how many dots we started with and how many we ended with. So basically we started at 1. Now let's say that instead we started at 2 or 3. So let's clear this for a second here. Okay. All right, so let's clear this, clear this, clear this, clear this. All right. Let's say that we're going to start with, so let's say we want the sum 2, 3, 4. So we're going to start with 2 dots, add 3 dots, add 4 dots. Okay. Now we can still take this and invert this, right? So what we would get is 2 more dots here, 3, and 4. All right? So it's not a square, right? Remember this, it's not a square, it's just the number of dots. So if we started at 2 and then ended at 4, we're inverting and adding that triangle back. So basically we're adding 2 and then 4. So this time we have 3 by 6. Okay? So this 6 here is the number we started with plus the number we ended with. And this 3 here is the number of terms we're adding. So let's say in this case 2, 3, and 4. So this is so n here is the number of terms we're adding. And that's the height of this geometrical shape, and the width of this geometrical shape is the start plus the end. And then to get the number of red dots, we will basically just divide by 2 after multiplying. So 6 times 3 is 18, divide by 2, so 9, right? So 2 plus 3 plus 4 is 9. Okay, so now that we have this idea here of doing this general thing, so what we're really doing is we're saying start plus end divided by 2 times it by n, which is the number of terms. Okay, so this here is going to be our little formula that we've come up with from using this triangle. Okay, so that's pretty interesting, right? So we did a little trick to add up the numbers 1 through 100. Now we did another little trick to come up with this idea for adding more numbers. So let's verify the adding of the numbers from 1 to 100 using our little formula. So if we're adding from 1 to 100, we're starting at 1. We're ending at 100. How many terms do we have from 1 to 100? We have 100 terms. So this is basically 100 over 2 is 50. 50 times 101 is 5,050. Okay? And so both match. All right. So now let's go a little bit deeper. So now, does everybody understand? So basically, we're going to do 2, how we came up with start plus end times n over 2. Okay, so we'll just make a note of that over here, n over 2 times start plus end. That's our little formula for adding up numbers. And it works regardless of where you start. You know, you can start at 2 or 4 and wherever you end. Okay. Now, all right, let's just clear this sheet. So our formula, let's remember, is n over 2 times start plus end. Okay. So let's say that we now want to add up, and so now let's say, so an arithmetic series, as you guys might know, is where you start at some number and then you add a difference and you keep adding it, right? So let's say that you start at 2 and then you keep adding 0.5. So you might get 2.5, 3, 3.5, 4, and so on. Up to, let's say that you wanted to add from 2 all the way up to 20. Okay, like this. So how many terms do you have? So if you started at 2, so let's say that this starting term is S, right? Just like here. And then difference is 0.5. So D here is 0.5. So now you have S plus D, comma S plus 2D, right? Comma S plus 3D. And you're going to keep doing this until you get to 20. So if you're doing that, 20 minus S is 2, so 18, divided by 3, not divided by 3, divided by 0.5. So if 20 is also S plus, so N is 0 here, 1 here, 2 here. We can say this is really N minus 1. But 20, so D is 0.5. Start with 2, so 18 divided by 0.5 is 36. So 2 plus 36 times 0.5, right? That's your 20. Let me remove this so I don't confuse you. So 2 plus 36 times 0.5. So if this is term 0, this is term 1, 2, 3, 36. So basically 20 is the 37th term. Correct? So okay. because this is the first term, this is the second term, so whatever the coefficient is, it's plus 1. So this is the 37th term. All right. Now that we know how many terms are there, we know that there are 37 terms. So if we take our n over 2s plus e formula, so we have 37 terms. What did we start at? 2. What did we end at? 20. Okay, so 22 over 2 is 11, so this is 37 times 11, which is 370 plus 37, so that is 407. Okay, so now you see, so basically using our little dots, we came up with this concept, and now we can also add up sequences like this where we started at 2 and we kept. Now, how do you write this sequence in a shorter form? You basically say it's an arithmetic sum, right? A of n is equal to 1/2 of n plus 2. So this here is basically this sequence here, and the sum, we call it the partial sum of the first 37 numbers, is 407, like we calculated here, right? So like if you plugged in n equals to 37, you will get, sorry, n equals to 36, you will get the 20. So n equals 36, you'll get 20. N equals 1, you will get 2.5. So really it's this minus 1/2. So it's really 1.5 here, right? So for n equals 1, you will get 1.5 plus 1/2, which is 2. And for n equals 37, you will get 18.5 plus 1.5, which is 20. Okay, so little minor correction. So an is 1 over 2n plus 1.5. That's just to adjust for that offset that we had of the 36 versus 37. So this is how you can do arithmetic series. And if you don't remember this formula, just feel free to, always draw out your triangle just like this. And you can quickly figure out that the number of dots is n start plus n, multiply these two and take 1/2. Right? So n over 2 times s plus e. That's how you can come up with that. And then the same formula basically can be applied to even not whole numbers, but like, adding by 0.5s or some other difference that you're taking. And that just works, and you can verify that by actually adding numbers. So, okay, hopefully this was useful. Now let us look at a more real-world scenario where this can be interesting, right? So Now you know how to calculate this, but where is this interesting? Let's say that you have a class of n students. So n students in a classroom, and each of them play a game with each other, and you want to calculate how many ways in which each person can get to play with each other person in the class. So sure, you can say it's n choose 2, right, if you know combinatorics, but we'll take a little bit of a different approach here. So what we're going to do is we're going to say the nth person plays n minus 1 games. The n minus 1 person plays n minus 2 games, right? Not including the first one. So let's do our example. Let's say that n was 4 students. So the fourth student would play 3 games. The third student has 2 more people to play with. The first student has... the remaining 2 students can play. And then the last student doesn't play by himself. And you're adding up all these games. So really, this is just adding up the numbers 1, 2, and 3 if you have 4 students. So what did we learn? We basically do start plus end, divide times n over 2. So since adding 0 doesn't make a difference, you can start at 1. So we can do start plus end, 1 plus 3, and multiply by n is now 3, 1, 2, 3 over 2, which is going to give you 4 over 2 times 3, which is 6. You could also just start at 0. So in that case, you have n is 4. So you'll have 3 plus 0 is start plus end. And 4 over 2. Right, so this time you have 2 times 3, which is still 6. So as you can see, regardless of whether you start at 0 or you start at 1, the formula will work. You just have to make sure that your n is the number that is the number of terms, right? So if you start with 0, you have 4 terms. If you start at 1, you have 3 terms. And then you can add from 1 and 3, or you can add 0 and 3. If it helps you, 0 plus 3, right? So, okay. So now you have 4 students. And you can also verify that 4 choose 2 is indeed 6. Okay? If you have n students, the same thing applies. Let's say that the class had 10 students. So if your class had 10 students, you can do 10 choose 2, or you can do 10 plus, or you can do n minus 1, right? Remember, for 4 students, it was 3 games, 2 games, 1 game. So it'll be 9 plus 8 plus 7, all the way down to plus 1, or plus 0, whichever way you want to do it. And if you go from 1 through 9, that's 9 terms. Start is 9, end is 1, so that's 9 plus 1 times 9 over 2, which is going to be 10 times 9 is 90 over 2 is 45. And you can verify that 10 choose 2 is also 45. Okay? So now I've shown you an example of how you might use it to figure out how many games would be played if 10 students played a game with every other student in the class. Okay, and there are many more such problems which you could solve with this. So anytime, the thing shows up, you want to add up all the numbers in an arithmetic series, let's say from, you want to go from 45 I don't know why my marker stopped writing, but all right, we'll just go ahead and end the video here. And I hope you guys learned.